10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Good afternoon, ladies and gentlemen. Welcome to the Asia Palm Oil Magazine webinar, which is titled Driving Geo-Precision Agriculture in Malaysia's Palm Oil Industry. I am Vanny, the MC of today. I wish everyone is having a great day and in a good health. So I am grateful that we can gather in this webinar today, together with our industry experts to provide some professional opinions about today's topic. Geo-Precision agriculture can address various technical issues within the palm plantation, such as identifying problems, monitoring changes, and managing variability. This webinar aims to bring a better idea and understanding to the audience on Geographic Information System, GIS, technology, and its benefit to Malaysia's palm oil industry. Audience will also have some insights on the current issues and predictions in the nation's palm oil industry. So let's hear from the experts on their take on the subject matter in this session. So for your information, this webinar is organized by the Asia Palm Oil Magazine team. And it is also in partnership with Fireworks Trade Media and Asia Webinars. And for your information, Esri Malaysia is the exclusive sponsor of this webinar. And ladies and gentlemen, I would like to introduce our speakers. First of all, we have Dr. Ahmad Parvez bin Gulam Kadir, Director General of the Malaysian Palm Oil Board, MPOB. Dr. Ahmad, you may introduce yourself to the audience.
Yeah. Hi, Assalamualaikum. I'm Ahmad Parvez, the Director General of MPOB. And we at MPOB, we are the regulator of the oil industry. So we do R&D of every kind of R&D from upstream to downstream. And we also regulate the industry in terms of enforcement, licensing. So basically the whole spectrum of the industry from upstream to downstream is within the responsibility of MPOB. Thank you, Vinny.
Thank you, Dr. Ahmad. Okay, so next we will invite next speaker, Mr. Look Ingting, Senior Consultant Industry from Esri Malaysia. Mr. Look, you may introduce yourself to the audience.
Hi everyone. This is Look here from Esri Malaysia, attached with the enterprise consulting teams. So we actually provide solutioning to the agriculture sector. So welcome everyone.
Thank you, Mr. Look. Next, we have Mr. Muhammad Zafrullah Salim, who will be representing Sime Darby Plantation Research Sdn Bhd. He is a scientist from R&D Precision Agriculture Unit. Mr. Muhammad Zafrullah, you may introduce yourself to the audience.
Hi, Assalamualaikum and good afternoon, everyone. My name is Muhammad Zafrullah Salim, and I'm a scientist in R&D Precision Agriculture Unit. And basically, Precision Agriculture Unit role is to provide reliable geospatial solution to Sime Darby Plantation.
Okay, thank you, Mr. Muhammad Zafrullah. Ladies and gentlemen, if you have any questions for the speakers during the webinar, you may share them at the Q&A panel. You share your questions at the Q&A panel, okay? The questions will be answered by the speakers or panelists accordingly. And we are also having a Q&A session to answer some questions from the audience during registration. Plus, good news to all the participants, as you will get to join a lucky draw to win a free gift, which is Jabra 85T earbuds prepared by Esri Malaysia. So stay tuned until the end of the webinar to know how. Okay, without further ado, I will pass to Dr. Ahmad Parvez, the Director General of Malaysia Palm Oil Board, to start the first presentation, which is titled Location Intelligence in Precision Agriculture. Dr. Ahmad, the floor is yours.
Okay, thank you, Benny. Okay, again, Assalamualaikum, very good afternoon to all of you. And let me... Okay, first of all, I would like to thank the organizer for inviting MPOB to share some of our experience in terms of looking at what we call precision agriculture. So I'm going to share with you some of our effort in terms of what we call location intelligence in precision agriculture, and some of the effort that at MPOB, and how do we assist the industry, especially the smallholders. So basically, the outline of my presentation, I'll be talking about the just a very brief introduction about the industry, and then the concept of precision agriculture. I'm sure most of you are already aware, who are expert in this field. And then some of the geospatial data development in oil palm, that what we are doing, and also the application of geospatial technology in oil palm industry, and finally just a very brief conclusion. So basically, I think just for information, I think the Malaysia remains the world largest producer of oil and fat. I think we account around 8% of the total global oil and fat production. We are talking about the whole 16 or 17 type of oil and fats. And we as a major player in oil and fat, we export around 17.37 million ton of palm oil last year, which represent around 18.3% of the total global oil and fat. We're talking about production. I mean, last year, we produced around 26% of the whole total 73.74 million ton produced palm oil produced in the world. And of course, the biggest chunk coming from Indonesia. And in terms of export, we export 34% of the whole 50 million ton of palm oil that has been exported. So we can see, comparing Malaysia and Indonesia, we are more in export rather than our local consumption. And this is basically our planted area. So basically, up to the data that we have until December last year, there's around 5.8 million hectares of oil palm planted. You can see on your right hand side where the blue color basically shows that around 72% are basically covered by the plantation, and then we have around the 16%, the cake in green color basically is this independent smallholders, and there's another around 11 or 12% of the organized smallholders under various schemes. And at the same time, you can also see the three images based on our GPS data and mapping that we are doing at MPOB. So we are basically showing that where are these oil palm planted. The difference is that, I mean, whatever you can see on the license, the 5.86 million hectares is basically based on our licensing data. Basically, these are all matured area. People only get licensed when they want to sell their oil palm. Whereas the maps are basically, this is where, whenever you plant, the moment you plant, we can detect that, then we will start putting the map. So that means the area on the map will be larger than the planted or licensed area. So basically, the challenge faced by the oil palm industry, of course, there are a lot of challenges. So some of them, of course, which is very severe now, is dependent of labor. So I think definitely precision agriculture will help us a lot in resolving some of the problem with labor. As I think there's a lot of report now with the COVID, the closure of borders and whatnot. I think we have a severe issues of labor shortage, and we also have seen that the production also have been reducing for a couple of months now. And of course, we have also issue with the less fertile land. I mean, we are basically exhausted with whatever land that we have, so we have to basically use whatever land that we have and try to increase the yield from the available land. And then I think one of the challenge that we have now actually is to how to interpret the yield map for site-specific management to identify and understanding the casual factors influencing the variability of oil palm yield, as we can see throughout the country. So, of course, the challenge is that how to increase the crop yield and profit. I think the yield, if you have seen for the past 20, 30 years, I think the yield has been stagnating, and unfortunately for the past 2-3 years also is slowly start declining. So this is not really a good sign in terms of sustainability of the industry. And of course, also how to optimize our field input, fertilizer, pesticide, etc. So this is where precision agriculture come in. And of course, this also help to minimize the environmental impact. I think now the industry has been accused a lot on environmental issues. And of course, finally, also important for the businesses actually how to reduce your production costs, while in that indirectly you will increase your profit and make it you more sustainable. So basically, in order to move forward, we use all these emerging technologies that are available. I mean, this is what MPOB have sort of proposed around 5-6 years ago. the way forward. So, but one of the big things, besides we're looking at productivity, food and nutrition, oleochemical, blah blah blah, value addition. But Internet of Things and also precision agriculture are two main important things that the way forward that we have to look. I mean, of course, the other issues on the mechanization, but I'm not going to discuss that. But this is very important of gathering all the big data with the Internet of Things and artificial intelligence, which is important to improve our precision agriculture, where we could actually make it more efficient and more sustainable. And of course, this use a lot of technologies, like you use drone technology. We'll show some of how we use those in our industry. I mean, our research, and then artificial neural network, hyperspectral remote sensing, robotics, and RFID. So these are some of the things, technology that is important for the way forward of industry. And just very briefly, I think the definition of precision agriculture is basically you just gather, process, and analyze all the temporal, spatial, as well as individual data, and then combine it to help you to support in management decision, where finally you would like to efficiently to increase your efficiency, productivity, quality. Of course, it end up with profitability and finally sustainability. So this is how people are using precision agriculture, and this is also sometimes known as site-specific farming. I mean, like in the medical, so we have now personal medicine. So now this also in farming, we cannot just generally use any recommendation of fertilizer everywhere throughout the country. There's no such thing. So this is where the precision agriculture will come in. So technologies such as GIS, GPS, remote sensing are all important to improve our agricultural practices. So at the end of the day, when we goes into use of the precision agriculture, it helps us to the potential to increase our yield as well as our economic return from the investment. So I think it also covers the whole spectrum, the whole aspect. Look at the agronomy activity, mechanization, pest and disease monitoring, as well as geospatial mapping. And of course, this is also very important in terms of pre-planning of plantation. For example, when you want to, whether you need to include terracing and whatnot. So this is also very important, especially when we also do your replanting and whatnot. Also important to have all this data. And initial work for precision agriculture requires basically to data, and this is what you have built up the plantation database. You need to gather all this information, and you also need to come up with site-specific fertilizer recommendation based on the foliar, nutrient analysis, and yield. This is what we're going to share with you later, some of the example. And of course, it's also improve our economic analysis, and also it's quite important to also to assess the risk at the early stage by using precision agriculture. So these are basically the cycle of precision agriculture. So you basically involve with data acquisition. This is where you collect million and million of data, and then later you go into analysis or analyze the data using various technologies, and this is where you extract the information from the data. And this helps you in terms of to support, I mean, decision to support your decision system, and as well as also help you to determine what kind of the required what we call the machinery, the variable rate treatment, as well as agriculture input, the different type of, as well as the amount of fertilizer and timing of fertilizer application. So it's just that basically help you to do the right thing in the right place and at the right time. And okay, so basically tools for what we call precision agriculture. Of course, you need all these tools. You need the GPS, GIS, and of course in MPOB we develop what we call OPRIS, All Palm Resource Information System, which I will share with you all later. And then we also have remote sensing, drone image, what we field spectrometer, and so on. And of course, you also need to have the data from yield to collect the data from yield monitoring, mapping, variable rate, fertilizer application, and so on. So this is something like some of the data that how you need to acquire. You look at the, maybe that this is one of our plantation. So we look at the, do the mapping of the oil palm block planted, and then we also do mapping of the oil palm age, the census, whether you are looking at the any disease or even you're talking about pest disease in the area, and you do the census, and then you also look at the slope, planting design, and so on. So all these data are all been put together, and this is where we come up with what we call the oil palm resource information system, or in short, OPRIS. So this is where we put. It's all based on GIS specific functionality for scientific investigation, resource management, and development planning of oil palm industry. So this is all where we put together the web mapping, web application, and a mobile application, and finally you have the whole system to assist us in the planting of oil palm. And of course, it also contains what we call this specific map function and so on. So this is, for example, one of the some of the data that we have. We look at, for example, this map shows the integration of the site yield potential, the peatland area, palm oil land use, agroclimatic information, and so on. So there's a very condensed information inside there, which of course the expert will be able to go there and then extract and get the right information to assist you into how to perform the precision agriculture. And basically, it's also important for the we're talking about land preparation. I mean, example, you are going to apply what the mechanization in the plantation. So it's very important to have this data. So from the mapping of the whole area, then you will know which area are suitable, which are not suitable, and also what kind of machineries and equipment need to be brought in order to operate in this particular condition or this new plant area that you're going to plant, and also help you in terms of determining the budget for basically operating in this area. And okay, you can also do what we call we also do the zoning, looking at the oil palm site yield potential. So this is where I think we collect the data from various palm oil age from different place and whatnot. So from what you can see on this map, it shows the based on the soil, agroclimatic, as well as the topography information. And what we showed there is the site yield potential. So those with the darker color shows you there are the higher yield. I mean, the darkest one will be more than 40 ton per hectare per year. And obviously the lighter color will basically have a lower potential in terms of yield. So this is very important in terms of determining the planted area so that you can get higher yield. Obviously, you can see from here, Sabah shows the highest area, and of course we know that Sabah also producing the highest amount of CPO currently in the country. And this also about the implementation of the precision agriculture in terms of in plantation. This is an example for the fertilizer application. So from the data that we have from the information on the ground, then we know when and what type of fertilizer to use, and also the quantity of fertilizer to be used. So in terms of the yield monitoring, and also helping you to get the what they call the site yield potential as well. So this is where we gather the information. This is the data to show that yield changes over time. You can see the data is from year 2001 to 2016. So all these 6 years we have all the data. So we also look at the yield as well as the foliar or nutrient status of the all these different sites. And of course we use what we call our open system, oil palm efficient nutrient system, to gather all this information, and this will help us to maximize our site yield potential. And this is one also example about special what we call interpolation map of yield and our foliar nutrient. So this is where example where we know the data of the yield and also the status of the nutrient, like example, in this case, nitrogen, phosphorus, and potassium. So we know which are sufficient or which is in excess, which is not sufficient. So this will help you to give you information about the potential yield. But of course, the yield are not only purely dependent on what we call nutrient, but also other factors like I mean the pest and disease, weather condition and whatnot. But the soil condition are basically, or the nutrient condition are basically the major role plays in terms of giving you the right yield. And of course, this is also some of the example of the yield and foliar status. I mean, this is something that we have done in our own station in Pahang. So we have looked at the yield for in 2014 and 16. And so we look at the 35 different points and look at the different what we call the nutrient. And then from this, all this data that we gather will help us in terms of how to proper plan our what we call planting in this particular specific site. And this information are also important in terms of how we could actually advise the industry. And then of course it's also involved with what we call the variable rate fertilizer map. So of course these are all important. I mean, this after you gather all your information from the various from the different type of what we call nutrient, like in this case nitrogen, phosphorus, potassium, magnesium. So once you know the status of this nutrient condition in this different this area, then you know what are the right fertilizer, what the amount required. It doesn't mean that we are going to apply the same amount to everywhere. So this is very important. It guides us to make sure that we apply the right rate of fertilizer at the right place, and also they mean to make sure that we get the efficient or the highest or the maximum FFB production. And in terms of based on this experience and also data that we have gathered, we then move to how we can assist the industry. In this case, we are trying to assist the industry looking at to develop the site yield potential for estate, and then as well as helping the smallholders through, especially through MSPO. And we can also help to map the MSPO certification scheme on the whole in the country, as well as I think the most important for the smallholders is that we manage and we help in mapping, as well as develop and assist them in good agriculture practices for the smallholders in the plantation, especially in their farm. So this is one example. We apply the application of Geo-Spatial for agronomy and fertilizer recommendation to estate and smallholders. So this is some of our effort, and these are some of the data. I'm not going to go into detail due to the time constraint, but this is some of what we are doing on the ground. And also this is, of course, where all this data has been put together. We have a dashboard to monitor the all the various part that where we have been working on. So this is something very important. Have good, strong what we call IT facilities to support. And I think the other important thing is actually in terms of agronomy practices. This is where we develop what we call our oil palm agronomy center, or OPAC. We have 3 centers in Terengganu, Johor, as well as Sabah. So this is where we help growers in obtaining the optimum economic FFB yield through practicing good agriculture practices, as well as the applying appropriate balanced fertilizer. So this is very important based on our mapping information that we have on the soil condition and whatnot. So we could actually help. Of course, we are doing it for free for the smallholders, but at a very small charge for the industry. But like example, we're looking at the soil and foliar. We do soil and foliar sampling, and then we do the chemical analysis for the plant, soil, and fertilizer. And then we also do agronomy and advisory visits, and of course apply or recommend systematic fertilizer recommendation basically to the smallholders. So this is something that we just basically started, and we are now try to get more equipment for our 3 labs that we have. So this will help. We have the geographic or the GIS data. So now it's more on the ground or soil sampling that we are doing, and also doing the lab analysis. So this is where we are going to expand more of this facility to the industry. And then of course we are also now using this technology for controlling the especially backworm. So one of the technology that we developed and we just I think introduced to industry last year is the what we call AutoBag, a sensor to sensors to detect the backworm. So basically through this technology we can actually distinguish between live and dead what we call larvae of the backworm. So this is still a work in progress. We are still improving it and then try to make it maybe to attach to drone and whatnot. So we could actually using this technology that we can later just have the drone going above the canopy, and then from there we can know which area have been affected. And the most important is that knowing the right stage of the larvae or as well as a pupae, live and dead, that will also will tell us where is the right time for us to apply the Bacillus thuringiensis to control the backworm. So these are still in progress, and we hope to soon really finalize this and then have a system ready to really control the backworm. I think certain part like Perak and Johor, we have serious problem of this backworm infestation. And of course, we also using drone and whatnot also to do sensors to look at the backworm outbreak. So all the red dots are basically area where we have the backworm outbreak, and then we also looking at area where we have put on the biological control. So we need to put more of this biological control, especially beneficial plant and whatnot, to reduce the repeated what we call incidence of backworm. So this is something that in progress, and we are using technology basically to control backworm. And what we also now also in the pipeline is also to integrate basically using what we call hyperspectral image for Ganoderma basal stem rot disease detection. So one of our, we have a few officers here looking at this technology. We're using what we call object-based image analysis (OBIA). So to suggest the detection and the moderate as well as severe Ganoderma disease infection. So we have the and this is around 90% accurate, where you can actually do early detection of the Ganoderma infection in the our plantation. So this is quite important. Always when we know it's quite severe, so now we want to get as early as possible. We're using this technology. Later we can attach it to a drone, and it can just go above the canopy and then can tell us, okay, these are part of the area where where there are very high incidence of Ganoderma. We can tell which are the plant are already early stage of infection. Then we could actually do some what we call curative, or at least we can do the mitigation to control the Ganoderma by using injection or whatnot. So these are some of the example of how we use these special technologies as well as all the image technologies, all the new technologies towards precision agriculture in the oil palm industry to ensure that we could actually assist in the long run how that we can fully implement what we call precision agriculture in the industry. So I think in conclusion, I would like to, sorry to rush because of the limited time that we have. So basically, we are trying to adapt the what we call geospatial technology in oil palm plantation to assist decision-making process and effective management. So basically, it's all basically gathering various data from various locations, various soil condition, various data that we have from various sources, putting them together. This is where you need a lot of mobile as well as what we call high-tech IT facilities to assist you to put them together. And then this is where we come up with this what we call precision agriculture technology that to help us to basically to move forward the industry more sustainably, and where we can reduce our input, we can increase our output, and then we can actually reduce a lot of wastage and whatnot by through doing the right rate of application of fertilizer, the right time of applying the what we call controlling of the disease and pests. And of course, finally, that will help us to even plan before we do a new round of replanting. And also, finally, we can actually maximize our outcome or as well as income from the industry. And obviously, I think that will always make sure that our oil palm industry already remain sustainable. Okay, with that, thank you so much for your kind attention.
Thank you, Dr. Ahmad. Thank you very much for interesting sharing. Oh, interesting. Technologies is very incredible, I guess, because it could help to improve our work efficiency. Am I right? So next, we'll move to the Q&A session. And for information, these questions were collected from the audience open registration. So Dr. Ahmad, we have first question here. For future planning, will there be any subsidy to be provided by MPOB to encourage the industry to invest in the technology?
Okay, that's a very good question. And I think currently there's no such what we call a subsidy or whatever fund provided. In fact, I think MPOB also we are still struggling. But it's also depend on government financial strength, as also demand from the consumer or the plantation. But I think currently, basically for most of the big players, I guess now with the very good price, I think as we know, the price is now very high. I think in 18 May this year, the price reaches 4,773, which is a record high. So I think, and a lot of companies are actually making a lot of profit. So I think for big players, it's very high time that for them to invest in this technology. I think with the profit they are making. Of course, for the smallholders, MPOB will have to, as we've been working on it, we are developing the technology and we will continue to assist them by using this technology.
Okay.
Yeah.
So yeah, is it done for first question?
Yep, right.
So now next will be the second question from audience. Are there any efforts by MPOB to produce planting material with a long stalk OP fruit bunch?
Okay, yep. I think I think long stock is one of the way forward in terms of assisting and harvesting. I think now we know we have issues with labor shortage, and also I think harvesting. I think there are a lot of, even I think recently we are working. We just established what we call MARCOP, Mechanization and Automation Research of Oil Palm Consortium, to basically solve the issue of harvesting. So obviously, I think long stock is something that a length of between what we call, we are basically looking at some of our planting material. I mean, because we got a lot of what we call oil palm that we collected from more than almost 20 countries from different part of the world. So basically, we thought long stock which have around 10 to 15 cm in length. And we have some, especially from the Angolian material, that have this kind of characteristic. In fact, I think MPOB have already introduced to industry what we call our MPOB Palm Series 10 or PS10, which is available. So any industry members who are actually interested could actually contact MPOB, and we can see how we could actually share some of this material, and people can start planting this oil palm, what we call this PS10, which can produce a bunch with the stalk length of around 28 to 36 cm. So this will be something very useful in terms of to ease you in harvesting. Of course, as an important commodity as well as a perennial nature, this promising long stalk material still need to undergo further round of yield improvement to achieve the commercial worthiness. Probably another 10 years, as they are currently still under experiment. So knowing oil palm, of course, once you plant it, you will be there for 25 years. So to get the 25 years benefit, you have to invest in time, because once you have, it is not like you plant today and tomorrow you get the result. So this is the patience required. But definitely there are something in the pipeline that we could actually assist the industry with long stock.
Hey,
Yep.
I guess good things always worth for wait, right? Okay, third question. Where could we find the urge for precision agriculture within the palm oil industry?
Okay, basically, I think we can actually use this precision agriculture in, like example, during replanting work. I think now we do a lot of replanting. pre-planning of planting design. I mean, for big players, I mean that when you want to do replanting, you can also help you in planting design. I'm not sure we are try maybe to do some studies on fertilizer, fertilizer application and whatnot, and also help you in terms of slope and terrace mapping. So because, for example, you have an area which is very hilly and whatnot, so this precision agriculture can help you. Based on the mapping, you can help you to design and create your own slope as well as a terrace. And this will help you in terms of when you plant later, you will have no issue with harvesting and evacuating your FFB. And of course, as we also demonstrated to the end, the disease and pest detection and monitoring can also be done using this what we call precision agriculture. Obviously, biomass, tree counting, and land use, land cover cropping, cover crop mapping and whatnot can also be done. In fact, we are also using a lot of our GIS now. This to actually, in fact, we are still at MPOB. We are finally at the final stage of actually doing the mapping of the whole oil palm planted in Malaysia. Because from what I say, we have around 5.9 million hectare oil palm planted based on our license. But what we are doing, our team is now working seriously. Of course, we have the satellite data, then we have to do the actual mapping, and finally we will get the whole data and we will be able to map the whole oil palm planted area in Malaysia overall. That means including licensed as well as unlicensed or area that are yet to be licensed. Because currently those oil palm planted which are less than 3 years old, they doesn't really have a license yet because they are not selling the fruit yet. So they are not in our data. But they are already planted. So for 3 years old, you can still detect them. So this is where we are also using this very what we call extensively to come up with our the map, which the government would like us to actually publish it so that the whole world can see our oil palm planted area. That's all.
Yeah, only 3 questions from chosen. So now, thank you very much, Dr. Amar, for your interesting sharing. And I guess everyone, you get to open up your eyesight, right? How interesting is it? Like how incredible technology could help in improving our working performance. So next, let us welcome Mr. Look Ing Ping from Esri Malaysia for his presentation titled Driving Digital Oil Palm Plant Operations in Malaysia. So Mr. Look, the floor is yours.
Okay, thank you, Vedi. Let me share my screen. So just checking, everyone see my screen?
I can see your screen now.
Yep. Okay. So thanks again, Benny, and appreciate the introduction. Salam sejahtera untuk semua. A very good evening to everyone. So again, my name is Look Ing Ping here. You can call me Look. Currently attached with Esri, the world leading geospatial solution provider, and specifically to Esri Malaysia, the distributor of ArcGIS system in Malaysia. So it is a great pleasure for me to participate in this webinar and speaking with you all. So for the topic of today's sharing, we will talk about what is geospatial and precision agriculture, and how this solution can drive the digital oil palm operation in Malaysia. Our work in GIS is actually simple: creating, applying, and understanding. We help users in creating data they want to monitor, applying analysis, and make understanding on the reality. So the effect that we actually produce is actually big because the user can actually make better decision on this. So before we go deeper to the oil palm solution, let me share with you our 2021 vision on GIS is actually creating a sustainable future.
It's all happened here. Everything we've ever known, done, loved, took place on this drifting, spinning ball that's our home. It's where we learned to provide, nurture, protect, thrive. And yet,
wildfires are scorching the West Coast, leaving behind a path of death and destruction.
Inches of rain this morning.
The waters keep rising, and according to the National Weather Service,
our very success now threatens our future. Today, our greatest challenge is to learn how to grow while sustaining what sustains us. Your understanding, your science, your work are the solution. You have the power to see patterns and relationships and show us how everything and everyone are connected. You have the power to transform how we produce and consume, build and maintain, unite and strengthen, heal and nurture. You can help us see that we can no longer live apart from nature, but must live as part of it. Today, geography matters more than ever. The geographic approach, your work, and the billions of maps you make are essential for creating a more sustainable future.
And yes, GIS is actually helping user to creating a sustainable future. So back to the context of oil palm industry, we all know that under the national agenda, oil palm today is moving towards sustainable development. And every planter need to get your MSPO certification and adopting the best management practices for them in order for them to continue in their businesses. We see today a lot of plantation company and operator from government GLC to private sector, from big organization to smallholder. Most of them are finding way to digitalize, transform their organization, especially in this pandemic time. So the aim for digital transformation is to let the industry become smarter, and your business activity is being operated and monitored more and more in real time. So the focus of digital transformation may vary from one company to another. However, this often boils down to the key driver, adoption of the reliable smart farming system. So what is the smart farming system? In the Industry Revolution 4.0, you see a lot of data we actually generate from everywhere. So look at the entire value chain of oil palm operation. Data could be generated from drone, area survey, from the field, mobile apps, from the real-time IoT sensor, on the big data analytics, as well as generated from the data science using the modeling and deep learning. And more than 98% of this plantation data collected with location element. We want to know what is happening where. And you need one system that can manage all this type of data in one place. Geospatial mapping technology, the applying geographic approach in GIS, Geographic Information System, is well adopted globally as an effective tool in precision agriculture. This to generate insight driving your business operation. So we name this geospatial technology as an ArcGIS system. It is a science of where. So ArcGIS technology is a common framework for collaborating and problem solving. Web mapping technology engage and interconnect everyone, from your user in estate using the mobile device to your organization using desktop and web, as well as to other stakeholders that access your information from public web. So our GIS system provides us with a framework and a process for creating and applying geographic knowledge, the foundation of our work. It allows users to work with different kinds of data. For example, as you have heard just now, IoT data, satellite imagery, 3D data, structural and unstructured data, and so forth. And all this data was collected, analyzed for us to understand it in a collaborative way, and then put it into action. This is the power of GIS and the power of geography-driven to make a better decision. And this technology is continue evolving and innovated. It's the powerful tool for GIS professional and as well as for the general user. It helps you to access network of distributed use service and content to modeling, being able to publish and share. Advancing hand in hand with all types of technology, as you can see already, imagery and remote sensing application on the Geo AI and machine learning framework, advanced spatial analytics and big data analytics, as well as integrate with enterprise system. So under the Geo agriculture plantation sector, Esri, we have also craft some Geo-Precision agriculture solution. There are many use cases developed using the market-leading ArcGIS software. But today, due to the time limitation, we'll run through these 6 fundamental areas that will foresee plantation owner can rapidly deploy the application for precision farming. These are the precision farming, Geo-Precision farming solution for land management, harvesting monitoring, replanting planning, water management, on the sustainability, and agronomy. Then you will notice there is a QR code at the bottom of the slide. Stay tuned until the end of this presentation for an opportunity to join Esri Malaysia team to book a consultation on one-to-one of this topic. So let us just move to the first solution quickly. So the first one is Geo-Precision land management. So we all understand that the most important asset in plantation is the land and farm itself. The land management solution is actually to move your land detail and planting statistics from the paper-based or Excel format to the cloud platform. So this is in order for you to easily access by your user, by everyone, anytime and anywhere. Land detail is actually referring to your area statement on your, for example, on the land size, planted area, where are the dispute area, and etc. Planting statistic is actually referring to your palm density, stem per ha, your year of planting, palm age, and etc. So all this will be made available inside this solution. So when the web map and data is accessible in the cloud, it makes the user easier to actually bring down to the field. So they can bring the map, work offline inside your plantation, and easy for user to do field auditing, as well as we can also use this as an MSBO internal and civilian audit. So Genting is actually one of our counterpart. They are actually using the solution to manage their landowner data. So land location and ownership is actually easily identified. So to avoid a duplicated land rental payment. So that's actually save millions of ringgit for this operation. There are many possibilities to expand the solution to cover other data. Our another counterpart, TSH Plantation, have developed the land management web map to include asset maintenance on the road repair, clearing, cover inventory, log bridge maintenance, infra inspection, soil profile, and agronomy. So everything is actually in one page. So they can actually monitor closely on all these expenses in the cloud system. So of course, we have we can include also the weather IoT data using the API. Later, you will hear from Saindabi on the experience in enriching land data with weather IoT for disease prognosis and application. So the second solution is the most important plantation activity of harvesting. So effective field data collection application using easy to configure smartphone without the need for you to know any programming language. You can actually configure a smartphone to collect the field data. So productivity indicator will be summarized into an interactive dashboard. And you could quickly retrieve data based on selection. So you could do the selection to find the production data by your zone, by your country, and by etc. So all the summarized figure will be actually recalculated based on your selection. So related historical production trend is actually important for you to identify the gap for production. And effective coordination between the harvesting activity with your farm fleet management is actually another way to increase your production collection. So in some of the users, they are actually integrate with their business intelligence tool, such as their ERP, SAP system. So the third solution that we are sharing today is to generate your replanting design blueprint in the digital twin before your actual implementation. So using the drone capability, nowadays it can actually quickly bring back the thousands of the area images in a short time and on demand. So palm counting is something that you can use Geo-AI capability from our system to count where is the palm, and this can be formed for future felling and chipping claim. So access to your road and drain density to add addition so that you will know whether your road is actually surplus or actually you need to add on some more. So you could work with a different scenario for the replanting design quickly. So for example here, what will be the density if I would like to have a planting distance of 8.5 instead of 9 meters? So you can actually work out a different scenario quickly in the digital twin without the need for you to try and error on the ground. So you can run and rerun again the replanting design model so that you will achieve optimum economical return for the next your 25 years planting. And most important thing is to bring all the design again back to the field. So the design will actually serve as a basic and benchmark for your field lining assistant. So move on. Let us look at the configuration, the apps application that we deal with sustainability. So in we have a living atlas that providing aqua and terra satellite image on the open burning. So this is for open burning monitoring. If you can scan this QR code, then you can actually go to that application. So then you can see how the thing can be monitored and managed. So, and of course, the RSPO is also using the ArcGIS online platform to share their certification area to the public. And also they will get crowdsourcing ability to monitor on the deforestation monitoring. So then they can actually file the grievances and they can actually take some action to monitor, to check, to verify whether the grievances filed is actually valid or not. Of course, if you like to handle, to monitor on your water quality data, so data can be actually pumped into the apps, then you benchmark with your national ambient water quality standard. So you can see whether your water performance is actually under the standard 2B set by the DOE. So this is something that will give you immediate alert if some of the data is actually go wrong. Of course, there are some others applications like biodiversity assessment and monitoring, health and safety on accident reporting and audit. And ScienceDB is also using the platform for them to enrich on the supply chain traceability. So a different kind of application can be configured to serve for your sustainability roadmap. And the fifth solution that we would like to share is on the water management. So basically on water is to register your water, river and drainage network. So this is important for you to know the flood level and determine the flood impact area with calculate. Then you, in order for you to calculate the exact affected pump, and it is important as a proof that you can actually use it for insurance claim, for example. And we can do some modeling like a flow accumulation modeling. So you will know where is your waterlogged area. And this is important for you to actually redesign your network. And some mitigation measure, for example, like drain desilting, bunding construction. So you can actually calculate what is the total length of the drain need to be desealed, and actually total length of bunding that you need to actually build to stop the water from coming in. So all this can be calculated in a great detail to form the budget before your actual implementation. So last is actually on the agronomy. As you can heard just now, MPOB, they have done correlating the soil profile and planting statistic on toward their plantation data. Then you can use that easy to configure quick capture apps to collect your pest infestation data from the field observation by actually just touch on the P&D sample picture button that allow you to quickly collect where is actually there is an infestation happen on the ground. So it's actually a different way of collecting data to faster your compilation for further analysis. Of course, we can do something on the palm health analysis and land use changes. And after you have collected so many image on the drone and satellite image, then you might need a system to actually catalog all these images for exploration. And then the agronomists can actually retrieve back what is the baseline images, what is the latest images, and maybe images 5 years ago, and allow them to do the desktop study. And so this is how we actually design the system and configure in different way to serve your plantation needs. To conclude on this, GIS has been now becoming interconnected. Nowadays, user is actually demanding for plantation data to be accessed not only from your desktop, but it need to be hosted in the cloud. Then accessed through the web, the apps, and then some of your content and finding embedded into your portal, as well as managed in your enterprise server. So this could be server to server integration. So in order to capture more data for you to actually generate business insight. And geospatial technology has building a common framework for stakeholder engagement. It's a good tool to engage different stakeholders, provide a platform for the team to work closely. It could be from your GIS professional to your subject matter expert, like plantation advisor, agronomist, to your user, state manager, R&D innovation manager, HR manager, mechanization manager, to your IT professional, like data scientist and team management. So the ultimate goal for using the GIS is building a strong foundation on the system of record. Each application able to handle different type of data source and interchangeable. Everything is actually on a common platform. So building the system of engagement that enable user from the different department to work together closely. And ultimately, in parallel, building a system of insight, generating a business intelligence through an executive dashboard in order to monitor, for example, on your revenue, on your CapEx, on your OpEx, and also managing your risk. So, and this will actually form the future digital plantation operation. So that's all from our sharing today. If you would like to know more on the presented topic, please click and QR code here. And in order, this will allow you to register for one-to-one consultation slot. So just pick one of the 6 topics that you would like to know further. Due to the time constraint, we cannot actually elaborate more on this, but we can actually discuss closely with you on the available date that you can select from for your consultation. So alternatively, if you access from your PC, we can actually share the link. I think the secretary can paste the link into the chat box, so you can actually put the consultation also from this link. That it will actually allow you to select a topic that we can actually provide further insight on what we can actually do for you. And that's all. With this, I hand over back to MC. Yep.
Oh, thank you, Mr. Luke. Thank you for informative sharing. So now we move on to the Q&A session. So the first question, okay. So how to implement Geo AI in the oil palm industry, and how much cost is needed to start up this technology?
Thank you again for the question. So actually the Geo AI it's something that embedded inside our product. So it's ranging from the desktop to this web and also to the server. So basically, if you are on our desktop, it actually have the capability already to do all this Geo AI and machine learning framework. So it will be no cost. So if you like to know how after you purchase your desktop or you already have a desktop, if you want to know how this thing can be benefited you, so just give us a call so we can actually do the demo on how this thing can be actually applied for plantation industry. Thank you.
Okay, so we have next question. Do we need any additional extensions, or could we apply this with the current version for replanting design?
Yep. Thanks again for the question. Yeah, of course, on the second solution on the replanting design, we need additional extension in order for us to do the modeling and to actually do prediction on where to site palm. So this extension required is 3D analysis and spatial analysis extension. To know further on this, again, we can actually discuss through more detail. Just reaching out to us, send us an email or put a consultation on this, so we can actually do the demo in detail with you. Yep.
Okay,
Thank you.
we have third question. Fire and hotspot monitoring. Okay, so can we also use this map to identify forest fire hotspots in our concession areas? If so, are there ways we can use the technology to mitigate any potential forest fire?
Yep. Yeah, this is a good question. So of course, hotspot is something that we actually receive the signal from the satellite images. So this data is actually made available to public through the NASA satellite Terra and Aqua. And in the living areas, we are actually can ingest all this data directly to our platform to do hotspot monitoring. And the good thing about this hotspot monitoring is to actually give you alert where is the potential area based on the heat index that they are actually monitor. So from there, ground truthing is still required for you to see whether this heat index is actually referring to the potential open burning activity or not. So then it is something that self-regulation. Then you actually detect early the hotspot, then you go to the ground to actually mitigate them and put off the fire. So it will allow you to control on your open burning activity, and it will not spread as a forest fire in the uncontrollable way. So I think Malaysia is actually doing quite good on this. So a lot of company, they already using this kind of data to serve as early warning for them to actually execute the ground truthing activity. So of course, this is applicable to the forest concession using the same method. So I hope that I answer your question. Thank you.
Thank you, Mr. Lo. By the way, just to double confirm, you will be sharing a link at the chat panel, is it? Or your team will be sharing it? So that this can reach to you. Yeah.
I think my team member can actually share the link to the chat panel.
Okay.
For that, for us to put the consultation slot if they intended to know more on the technology.
Yeah, so that if let's say attendees they have any inquiry, they can reach to you directly.
Yes.
So yeah, that's all from Mr. Luke's side. Thank you very much for your sharing. And now, without further waiting, let us welcome Mr. Muhammad Zafrullah Salim from MPOB Plantation Research Sdn Berhad. So he will conduct some testimonial sharing, which the presentation is titled Empowering IoT in Oil Palm Industry Through GIS. So Mr. Muhammad Zafrullah, the floor is yours.
All right, thanks, Vinny. So first off, let me share my screen. Right. Okay, hello everyone and welcome to the session. I will be talking about empowering IoT in oil palm industry through GIS. And I will be focusing on weather data IoT from MPOB Plantation owns experience. Okay, to start off, let us take a look at our palm oil industry. The worldwide palm oil consumption for the past 5 years has been increasing, and this trend will continue to do so as the world population keep on increasing as projected by the United Nations. And among other vegetable oils in the world, palm oil is the largest vegetable oil being consumed. And in terms of land use and production, oil palm produce way more compared to other oil crops and with less planted areas, right? So here at MPOB, we have close to 600,000 hectares of oil palm planted that span across 4 different countries, including Malaysia, Indonesia, Papua New Guinea, and Solomon Islands. And we are the world's largest producer of certified sustainable palm oil. And the challenge is that we're able to meet the increasing demand in the next 30 years, as projected by United Nations. The population keep on increasing. And it's certainly exploring new land is not an option. And therefore, we need to grow our crop more efficiently than ever before. So with that, MPOB Plantation established a precision agriculture unit since 1997. And the role of this unit is basically to provide reliable geospatial solutions along with recurrent technologies to improve MPOB Plantation operational efficiency for effective decision making, right? Talking about current technologies, let's talk about the current industrial revolution. We've came a long way since 1700s, starting from steam technology to electricity to computing, and now it's all about connectivity. And the 4th industrial revolution is basically the ongoing automation process of the conventional industrial practice with machine-to-machine communication, and IoT has been a forefront. So with Industrial Revolution 4.0 came along Agriculture 4.0 that highlighted the sustainability, quality, protecting the environment, and reducing waste and cost in terms of agriculture production. And the agriculture sector right now is going through digital transformation. And on top of that, the COVID-19 outbreak has showcased the true value of the digitalization in the sector. And there was a surge amount of investment, especially in agriculture technology for the past few years. And this report is just the tip of the iceberg. Speaking about iceberg, one of the key issues that has been highlighted in Agriculture 4.0 is the climate change. How does climate change impact our industry? According to a climate change report in 2017, the uncertainty of weather condition has risen the frequency of droughts and floods that will affect our crops. And the rise of sea level will greatly affect our coastal areas. And our pollinators also are at a greater risk of being exposed to new diseases. Not to mention, the pest and disease is also expected to be more aggressive than ever. And all of this will result in our crop, a loss of crop yield, right? So how do we tackle all of the issue that has been highlighted in Agriculture 4.0? By focusing more on precision agriculture. And with the current available technology, such as drone, big data analytics, Internet of Things, and artificial intelligence, we can utilize them to better understand the output practices and understand what changes can be made to generate the greatest value. And today I'll be focusing more on GIS and IoT. And let's talk a bit about GIS technology. Back then, when GIS was first introduced, GIS is basically a tool only meant for the professionals, meaning that you need to have a certain level of knowledge or certified knowledge to be able to use it. Fast forward to today, GIS technology has been part of our daily life without we even notice. Right? My point here is that we can see the evolution of GIS technology coming from a tool that is exclusively for professionals to being available for everyone to use. The second thing is the Internet of Things, or IoT. So IoT is the short for Internet of Things, and it is basically a system of interrelated physical objects, or as we call things. So these physical objects have the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. So how does it work? So let me give you an example. Let's say we have a weather station with embedded sensors with it installed in the field. So all these sensors will automatically record all the weather data and transmit via IoT gateway and store it in the cloud storage, right? So this data in this cloud storage will then be analyzed and visualized to be consumed by the users via the mobile devices. Very straightforward, right? So what is so great about GIS and IoT anyways? Before I get into that, let me explain to you how we conventionally record weather data before IoT came into the scene. So this the picture on the right is an example of a rain gauge, which is a device to record rainfall data. And basically, a person or a recorder have to physically be there every day at a designated time to check whether or not there's a presence of water or precipitation in this rain gauge. And if so, the recorder have to remove the rain gauge carefully without spilling any waters and pour it into the measuring cylinder and measure it and record it in this form, all right? Then we've transitioned into using semi-automated weather station. So with this weather station, we don't have to physically be there every day to collect the data because this weather station have all the weather sensors embedded with it and automatically record all the data into a data logger. But the thing with data logger is that it has limited storage capacity that can store up to 7 or 8 days worth of weather data. So we still need to go and retrieve the data every week. And another caveat for this weather station is that we could not monitor the status of the battery for the weather station. And it happened to me multiple times whenever I went to retrieve the data, the battery of the weather station has been dead for a few days. And this has prompted me to visit the weather station frequently. Then we transition into the automated weather station with IoT connection. So with this weather station, we don't even have to physically be there to retrieve the data because all the data that has been recorded is being stored in a cloud storage, and we can view it in this designated web page, right? But the thing about this web page is that only one person, obviously the person in charge, only one person can view and manage it at a time. And this designated web page is meant only to monitor and manage the weather station, whether or not the weather station is doing fine and so on. And it's not meant for visualization and also sharing. And to sum it up, the conventional way of recording weather data required trained personnel because it has to be manually measured, right? And mentioning about manually measured, there is a tendency to have human error in it. And that being said, it led to data integrity issue. To be frank, I witnessed how the rainfall data being recorded without even going to the rain gauge itself. And another thing worth mentioning is that most of the time, all these rain gauge are poorly maintained, right? And the location of this rain gauge itself is not suitable to collect rainfall. So all of this will amount to the inaccuracy of the data itself. And even so, all the data that has been recorded are often not fully utilized. So coming back to the question, what is so great about IoT and GIS? So this is the answer. With both IoT and GIS, we could develop a weather monitoring dashboard that ensure all of the issues be taken care of, right? But with this, it is only meaningful if it's being shared and consumed by the stakeholders, right? Especially those in the estate operation, the agronomists and crop protectionists, right? And therefore, we have created a single geospatial platform called SMART. So with this platform, we can share all the data in this platform, and all the departments within the organization can access to the data anytime, anywhere. And we are more interconnected to each other than ever. And this does ensure data integrity, it improves transparency across departments, and also avoid duplication. Right? And one of the things that we've developed is the Smart Agronomy Hub. And basically, people on the ground can report or log any issues that they found using their mobile devices. And we have also developed this vitality index dashboard to assist them and predetermine the areas that they need to visit. Okay, and the latest addition to this agronomy hub is this weather monitoring dashboard. So I'm going to give you a demonstration of this dashboard. Right. So right off the bat, we can see all these weather panels here, and we have a map of the location of our weather station. And the left side of the dashboard, we have the station list and a big panel here that shows total active stations and also this heat index gauge panel. Right, so let me proceed by selecting one of the estates. So I'm going to pick this 200 estates. Right, immediately all of the weather panels have changed according to the estates that I've picked. Right, and we go to this left side of the dashboard, so we can see a quick overview of the hourly data that has been captured for the day. Right, and we also have this heat index gauge for this particular estates. Well, for those who don't know, heat index is basically a measurement of temperature that combines with relative humidity, meaning that high heat index indicates that area is very hot and very humid. So for this particular estates, we have, and this heat index gauge, we have classified to three classes, which is the low, medium, and high heat index class. And for this particular estate, it is within the low range of heat index, so nothing to be worried. And before I forgot to mention that is all this weather information is in real time and it's being automatically updated hourly, right? And to give you a brief example of how important this real-time data is, let's say for example we are going through wet season, right? So during wet season, we have a threshold of how many rainfall that we can receive in order for us to decide whether or not to continue manuring for the next day. Right? If it exceeds 25 millimeter of rainfall, then we should stop manuring for the next day. Imagine if we don't have real-time data and we need to rely on rain gauge. We need, if we rely on rain gauge, we need to wait at least the next day until the recorder have recorded the rainfall data. Only then we can decide whether or not to continue manuring. But with real-time data right now, as I demonstrate here, so this is the latest one, 4 p.m. I can decide right here, right now, oh, today, Dusun Duda Estate have no rainfall, so we can continue manuring for tomorrow, right? So it's as easy as that, so that we can, especially those in the estate operation, can manage their resource and schedule ahead the task for the next day, right? And if you notice that all of these weather panels have a pattern panel behind it. So this is basically, let me enlarge it, the historical pattern of the weather data. So for this, we have rainfall data since the beginning of the year, for the whole year. And we have a time slider here, so you can slide to any specific time you want, right? So what we can do with this piece of information is that we can compare this with our yield performance, for example, right? So that we can see is there any effect of our yield performance in relation to weather changes, okay? And we could also apply that in pest and disease. So for example, we have the threshold here that says that if we receive less than 26 degrees Celsius, then the possibility of a backworm outbreak is there. So with this piece of information, we want to create the awareness, the operational awareness, so that people on the ground are aware on the current condition of the weather in their respective estates, right? So they can make necessary adjustment if they need to, okay? And one of the things that I want to highlight is that we have this battery level status that we can monitor because we do have incidents where one of our weather station, for example here, battery status suddenly dropped, so we can alert the people in that respective estate to go and take a look at it. Right? And another thing that I want to highlight in this dashboard is that we have this heat map. So this heat map is basically an overview of the current condition, current weather condition across our estates. And for this heat map, we are using heat index as an indicator. And you can use whatever weather parameter that you want. If you want to have an overview of the rainfall across the estate, you can, right? And another thing that I want to highlight is that this early warning map. So basically, this map is a tool for us to identify which of our estate that receive or suffer through an extreme range of weather condition in a certain period of time, right? Okay, so for example, here I'm going to monitor heat index, right? For the last 2 weeks, so I'm going to set it to last 2 weeks, right? And then let's set from 50 to maximum, right? So when we click here, we get a figure of, okay, we have 5 estates that have been receiving this extreme level of heat index. And when we click this warning list, it shows us which estates and when do they receive this extreme heat index measurement, right? And again, this piece of information creates awareness so that people on the ground can be alert and make necessary adjustment. For example, to frequently check their water level, or so on and so forth, right? And for this dashboard, we also have a mobile version. So to cater for those who are working in the field, right? So basically works the same, choose any estate they want, and all the information will show up, right? Although it lacks the function and features as the desktop version, but it is enough for them on the ground to get by. And again, this dashboard can be accessible to everyone within the organization through our smart hub, right? So with both of this IoT and GIS, it opens up a lot of possibilities, right? And as I mentioned earlier, that the data collected are often not fully utilized. So this is how we can fully utilize all the collected data. That we can develop a yield forecasting model, can also develop a pest and disease outbreak prediction model, right? And I noticed that we have this huge knowledge gap in the field in using weather data in oil palm plantation. And with the help of IoT and GIS, I believe we, the industry, could fill this knowledge gap, right? And just to give you an example of how we can utilize this IoT and GIS, we can develop an early warning system for, in this case, the example is the backworm outbreak warning system, right? So with this, with IoT data and a bit of help from artificial intelligence, we are able to come up with this warning system with high accuracy, right? And then this piece of information is very useful for those in estate operation because it gives an ample time for them to manage their mitigation effort and also a perfect window for them to execute their mitigation efforts, right? And imagine that if we can put this information or this system within the dashboard, and the dashboard, if we put this information within the dashboard, and it could notify the users whenever there will be an outbreak, so that the people on the ground can be notified if all this weather condition has been met and there will be an outbreak, right? So they can prepare and execute their mitigation efforts, right? And imagine if we pair that with location intelligence, which is or GIS technology, we could pinpoint the exact location on where to execute the treatment, rather than blanketly applied to all the field. And this is how we can harness both IoT and GIS, the power of both IoT and GIS. And in turn, it will reduce cost, reduce time, and increase the efficiency of the mitigation efforts, and overall improve sustainability. Right? So what have been demonstrated and showcased in relation regarding IoT and GIS, I hope it can be an eye-opener or could enlighten all of the audience here today. And we have to admit that precision agriculture is the future of farming. And the way the conventional ways of doing things for all this while has its flaw and has put the industry in a comfort zone. And to my personal experience, we have been in this comfort zone for far too long. And from now on, we need to change things. And I know, and I very well understood that change can be scary and change can be difficult. But in order for our industry to prosper and be relevant in many more years to come, that change is necessary. And I personally wish that everyone in the industry can be on board in enabling agriculture 4.0 so that no one gets left behind in this fast-paced technology era. And with that note, I'll end my presentation today. Thank you. Back to you, Veni.
Thank you, Mr. Muhammad Zafrullah. Yes, I guess the only constant is change, right? Okay, so now let us move to the Q&A session. Let us see what is the first question from the audience. Okay, so what were some of the challenges faced by Sam Darby that prompted them to use GIS?
Okay, if I wanted to choose, I think it started when we trying to replace hand-drawn mapping to printed mapping. I think that's the start of the spark that's from us to use the GIS. I think that's started from that. It started to snowball the use of GIS until today. And because of this hand-drawn mapping, we were wondering why couldn't we print this map rather than hand-drawn, right? So in order to produce a digital map, and in order to produce printed map, we have to digitalize the hand-drawn map. And in order to digitalize hand-drawn map, we need to use GIS technology. And therefore, I think that's probably the biggest reason that prompted Sam Darby in using GIS technology.
Okay, so I guess first question is done answering.
Yeah.
Okay, so next question. How did you promote the use of GIS technology to a wide variety of stakeholders and users?
I think the best way in promoting what we want to promote is to let the users get a taste of it. And for our case in Sam Darby is that we introduce them to a PDF map, a printed map that has been transformed into PDF version with all the geospatial component in it. And we also introduce a few mobile application that can read this PDF map and act as a navigator for them to navigate in this field. So when we introduce them to this, words travel fast and suddenly everyone wanted to use. So this is how we promote the use of GIS technology. And also we introduce Google Earth to them so that when we provide all the relevant data, such as the estate boundaries, field boundaries, road layers, so they can, they can do them themselves, they overlay all the data themselves, and they can also analyze what they need to with all of this GIS technology. And forgot to mention that when we introduce them to this mobile application and web application, all of them are free to download. So it is easier for them to use and to access and to utilize fully using this GIS technology. And ultimately, I think through our smart agronomy hub, I think this is one way that that we can promote a GIS technology across different departments, whether you are in finance department or anywhere within the organization, so that with this smart agronomy hub, In return, we'll showcase the importance of GIS technology and also provide useful information to the stakeholders and users.
Okay, thank you, Mr. Muhammad Zafrullah. Oh yeah, we still have third question. So what has Sime Darby achieved so far with precision agriculture, and what is your view about this digital in the near future?
With precision agriculture, actually, the achievement that we have with precision agriculture can be divided into three different categories. One is science, data, and also technology. So first about science is that with precision agriculture, we've managed to develop many things. Have you seen earlier that with our vitality index dashboard, we also have our palm counting model using high resolution satellite image or drones, and we also have multispectral imaging and extracting all the spectral profile of unhealthy palms, can monitor the health of the palm, even measure the height and the size of the crown, right? So that's the science part that managed to achieve. And in data part is basically digitalize all the geospatial data, right? And also we have transitioned in terms of using pen and papers by using mobile devices, right? So it's much more convenient. And third is about the technology. So the technology that I've showcased just now is through the dashboard, the web app applications, right? And eventually all of these science, data, and technology will eventually be shared to our Smart Agro Hub, and so that everyone can have access to it. And my personal view in regards of digital in the near future is that this digitalization is the next big thing. I'm sorry, it's not the next big thing. It is the biggest thing now, and it is happening soon as we expected, right? And also I've mentioned that precision agriculture is the future of farming. And I think with digitalization in the industry, it gives us more control over the crops so that we're able to adapt, predict, and proactively act according to the environmental changes. And ultimately, it helps us in making well-informed decisions, right? So I hope that we could band together and undergo this digital transformation together within the industry, so that we can be more relevant in the near future, right?
So yeah, so we're done for question 3.
Yep.
Okay. And yeah, thank you very much, Mr. Muhammad Zafrullah. So ladies and gentlemen, our webinar has come to an end, and thank you everyone for your participation. So if you have any inquiries, welcome to write to our general email, or yeah, our team will liaise with you accordingly. Okay, so feel free to visit our website at www.asia-palmoil.com for more information about us. Also welcome to follow us on Facebook and LinkedIn at Asia Palm Oil Magazine to get the latest information of news. Last but not the least, here is the good news for all the participants. Still remember what I've mentioned about the lucky draw at the beginning of the webinar? So here it is. Fill in this post-event survey now to enter the lucky draw competition to win Jabra 85T earbuds. Whoa! So kindly scan this QR code, or you may click on the link provided at the Zoom chat panel to fill in the survey form. So the lucky draw winners will be informed by Esri Malaysia in 15 working days after this webinar. Okay, so guys, you either can scan this QR code, or you can get a link to enter the lucky draw. So again, appreciate Dr. Ahmad Parviz, Mr. Luke, and Mr. Muhammad Zafrullah for spending your precious time with us. And thank you everyone for your time as well.